What is staying the same in each of these pictures? Who said that? Okay, I don't want you to answer because you got the number or the amount. What is staying the same in each of these pictures? Who said that? The 5, right? So we've got 5 here, right? We've got the 5 here. We've got the 5 here. And we probably would have the 5 also, okay? So then when we go to figure number 2, what is happening? What's going on with that 5? What's going on? They quadruple, which means adding 4, right, in the corners, right? So here, this is 4. Here, how much is added? Plus the 5? 5 plus 8, right? Because you're adding another 4. Now, it is 4 each time. 4 times what gives you 8? 2. And how does 2 relate with figure 3? Because I think you always need to try to relate it with the figure number. Maybe I'm not asking it well. So each time we have 5 plus, we have 4 times. How are we getting this number compared to the figure number? It's always 1 less, right? Now, is that how you did it? No. Okay, well, this is one way, and then I'll have Cameron explain her way in just a minute. So figure 15, oh, she said 61, I think, right? I somehow asked that. So I see it as being 5 plus 4 times, since it's figure 15, it is 1 less than that, which is 4 times 14, which is 56, plus 5 is 61. That's how I see it. Okay? Again, there's many different ways to do it. So Cameron, what did you see, or how did you put that together?
I just like the little square in the middle, I took that out, and then since it's going up by 1 on each side, I did 15 times 4, and then plus 1.
So you took out the centerpiece, right? And then it's going up by 4. And so this would be 4 times 2. Ah, okay. So you basically said and looked at the 1 in the center that was the same. So for figure 15, her way, it is 1 plus 4 times the figure number itself, right? So for figure number 15, it's 1 plus 4 times 15, which is 60, plus 1 is 61. So everybody see that? Yeah, so again, there's multiple ways to do it. Che, did you have a different way, or how did you come up with 61?
Well, it's kind of the same way.
As Cameron's? Okay. And Nehemiah, did you have 61?
Yeah.
How was your method, or what was your method?
I saw that 4 was being added, right?
Okay,
4
yes.
was being added each time, so I just kept doing that.
Okay, so I think that was the same as Cameron's too. Yeah, good. All right. Any questions about these? Are you liking these? Are you getting them a little better? Or are they still kind of little? Okay. All right. Now, before we go on, I want to tell you and talk to you. What do you think you need to do to be successful in this class? If I told you there were 3 basic things, what do you think they might be to be successful in this class? What would you need to do? Trying? Yes, in a matter of way, yes. Trying, I would say participating, okay? Participating, you have to try the problems, you have to participate. What's another thing to be successful? Trial and error, okay. I would say maybe that's still participating, I would say, kind of, because you have to do it, right? What else? If you want to be successful in this class, participate, trial and error, that's all kind of the same.
I would say be like attentive or pay attention.
Pay attention, yes. Pay attention. Along with that, maybe ask questions when you're not sure. You have to actively participate, okay? And then finally, what else? Probably work on the homework, okay? So those three things, if you do those things, so if you participate in class, actively participate by doing what you're expected to do, ask questions when you are not sure, and especially if I explain it and you don't understand it still, and then finally work on the homework. You do those three things and you will be fine for this class, okay? So let's try and see if that strategy works. I hope to see everybody using those as we go along. All right, so let's open up our workbooks now to page 61. And this is similar to what we did yesterday. This is called university population. Now, did we get through two of these? Okay. Because my other class did not. So we already did these two, right? Okay. So here's the third one. Just to help refresh your memory, it says, let X and Y denote the number of male and female students respectively. So the males are the X's and the females are the Y's, where X is less than Y. If possible, determine which of the expressions is larger by interpreting each of the expressions in terms of population. So they're trying to say what's going on in each of these expressions. So the first one is X minus Y divided by 2. X minus Y divided by 2. Now, what is this representing? X minus Y divided by 2. What does it mean in terms of the population of male and female students?
The count of all students subtracted by each other divided by 2.
Mm-hmm. So specifically, starting with which group?
All students.
Not starting with.
Male students subtracted by the female students.
Yes. So it's going to be male students, and the number of male students, we should say, minus the number of female students. Okay. And that is all, once we have that answer, divided by 2. Okay? So the male students minus the female students divided by 2. Now, that's not a very easy thing to talk about as far as what it means in terms of the population. But hang on to that for just a minute, and let's look at the second expression, which is X all divided by X plus Y. Now, what is this represented as in the population of the university?
Bro, male students divided by all students.
Number of what?
Male students.
Okay, so this is the number of male students, because that's your X value, written as a fraction out of all students. Okay? So, as I think about these, the first one, male students minus the female students divided by 2. And the second one, number of male students out of all students. Which of these is going to be larger and why? Which of these expressions is going to be larger? Somebody I haven't talked to. Is that a hand up, Andrew? Are you sure? Okay. Jamani, talk to me about that first expression, x minus y all divided by 2. What kind of an answer am I going to get there? X minus y, number of male students minus female students. And what do we know about male students and the female students in general? There's more females. So when I say male students minus the female students, what is that going to be in the numerator? Say it again. Yes. If you have fewer male students, was that a hand up that time? Oh, you gotta quit. Do that. Okay. Your number of male students is fewer than the females. So when you take the male minus the females, that gives you a negative answer, right? And then you put that over 2, that gives you a negative fraction. All right? So the answer here is a negative fraction. So it's a negative something over 2. Does everybody see that? Okay. So then talk to me about the other one. X all divided by x plus y. What kind of an answer is that going to be? What kind of an answer is that going to be? Is it going to be a whole number? Is it going to be a fraction? Is it going to be positive? Is it going to be negative? It's going to be positive. Why is that? Because it is, right? And what else? Number of male students all divided by all the students. It's going to be a positive what? Fraction. Right? I mean, it definitely is a fraction because there are fewer male students than there are all students. And so which one is larger? The first one or the second one? The second one, yeah, because the first one is negative. A negative is always going to be less than a positive. All right? Again, we have no idea what the population is, but just in looking at these expressions, we can determine that information. Questions on that one? All right, let's turn the page. We got more to do. This is some independent practice. Says, for each pair of expressions below without substituting in specific values. So don't put in, t is 1 or t is 5. Without substituting, determine which of the expressions is larger. So we have 1, 2, 3, and 4. Okay, I want you to work with a partner or a small group. Now, if you really want to do it alone, you can. but I think 2 or 3 heads working together are better than one. I'm going to give you about no more than 5 minutes. Okay? 5 minutes. So, which of these is larger in each case? Which of these is larger? And then explain your reasoning in a sentence or two. All right? 5 minutes. And I'm going to be walking around. I might be asking you some questions. Whatever. All right. For each pair, without substituting, determine which is larger. So 5 plus t squared or 3 minus t squared? The first one or the second one? Which one's larger? The first one. Why? There's that question. I tell her the right answer, and then she wants to know why. Yes, Andrew. Obviously. Right. And it's t squared, so whatever that answer is, it's going to be positive anyway, right? So 5 plus a number is going to be a larger number than 5, whereas 3 minus that same amount is going to be smaller than 3. Okay? So, I mean, you could say 5 is greater than 3, and then 5 plus adding is going to be greater than 3 minus the same number. Something like that. As long as you understand it. These are your notes, okay? I'm not going to be checking your notes. Any questions on that one? All right, let's take a look at the second one. 15 divided by x squared plus 6, or would you have 15 over x squared plus 7? Which is larger? Which is larger? This one's a little trickier. Think of these as representing maybe, I don't know, some kind of candy bar, and you want the most of that candy bar that you can get. 15s, talk to me about that. 15s are the same, right? So really you're looking at the denominator, what's in the bottom. Which one of these is bigger on the bottom? Okay, so this is the larger denominator, and this is the smaller one. So if you're talking about a candy bar and you like the candy bar and you want it, would you rather have 15 pieces out of a larger size candy bar, or would you rather have 15 pieces out of a smaller sized candy bar? Which one would be bigger? The left or the right? I don't know what you're pointing to. The right? So like this? This is the bigger candy bar. Is that right? Would you rather have 3/4 of a candy bar, or would you rather have 3/100 of a candy bar? You want the biggest part of the candy bar. So the smaller the denominator, you get more, okay? So it's actually the other way around, right? Because you're getting 15 pieces out of a smaller amount than 15 pieces out of a slightly larger amount. Isn't that weird? I mean, this isn't difficult, but you really have to think about this, don't you? Crazy. Okay. Questions on those two? Does that make sense to you? Let's go to the next one. So s squared plus 2 times quantity s squared plus 1, and comparing that to s squared plus 4 times quantity s squared plus 3. Which is larger, the expression on the left or the right? Come on. Cameron.
You're right.
is bigger? What do you guys think? Pierre's like, yes, I knew that, but I was wanting to make sure everybody else said. Why is that bigger?
Because 2 is bigger than, no, 4 is bigger than 2, and then 3 is bigger than 1.
Yeah, s squared, that's always going to be the same amount, and then 4 is bigger than 2, so that's going to be a larger number multiplied by a larger number compared to that. So yes, first one is less than the second one. Questions about that? I don't even know what to write there. A smaller times a smaller number is going to be less than a larger number times a larger number. Something like that. All right, and this one, the last one, I think this one is probably the most difficult. Any ideas on this one? Sajan? Okay, and why do you say that? Okay, so you're dividing. What are you assuming about this amount? Okay, you said you're dividing, so 8 divided by that amount. What are you assuming about that denominator? Gosh dang it. Are you assuming, gosh, I can spell, I promise. Are you assuming that it is larger than 8? Maybe you're assuming that the denominator is larger than or greater than 8, which would make this a fraction. Okay? But let's actually put some numbers in and see if that's always true. So if k is equal to 0, what do I get for my expression over here? I get an answer of 4, right? Because I get 8 divided by 2, which is 4. Over here, I get 0 squared plus 2, I get an answer of 2. So for this one, the 4 is greater for 0. So let's try 1. 1 squared plus 2, that gives me 8/3. Over here, 1 squared plus 2 gives 3. Which one's larger, 8/3 or 3? 8/3 or 3? It's actually this one, just by a little bit. So what if k was equal to 2? 2 squared is 4. 4 plus 2 is 6. That gives me 8/6. Over here, when k is equal to 2, we get 2 squared plus 2, which is 6, which is larger over here. So yes, most of the time, except when k is equal to 0, this side is always going to be larger. And you might make that, except when k is equal to 0. Okay? All right. Questions on that independent practice? All right, I got one more for you. So turn the page, or go to the next page. You have to have a pencil for this. Okay? So we're on page 63. In Prague, some sidewalks are made of small square blocks of stone. The blocks are in different shades to make patterns that are in various sizes. So here are the patterns. We have pattern number 1, pattern number 2, and pattern number 3. So on page 63, not page 16, I want you to draw in the next pattern of that series. So take a look at the pattern, and I want you to draw in the next pattern in that series with either the gray or white blocks. with either the gray or white blocks. So take some time, draw the next pattern, and then start to answer the questions on the next page. What was that? It's like something fell down.